Hello students, in this session we will discuss about the flow through pipes, and we'll be discussing about the major and minor losses in pipes and its corresponding equations. And before starting with the losses of energy in pipe, the Reynolds number in the pipe flow. The value we can discuss first. That is Reynolds number. If the Reynolds number is less than 2000, it is said to be the laminar flow, and if it is more than 4000, the flow is said to be a turbulent flow. I will already know what is a laminar and turbulent flow is. And coming to the loss of energy in pipes, in this first one, it is first classification is major energy losses, and the second one is minor energy losses. In the major energy loss, the only thing, the major energy loss which happens in the pipe is only due to friction. So the frictional losses in pipe is said to be the major energy loss. Whereas in the minor energy loss, it is divided into different types. That is, first one is sudden expansion of pipe, and if there is a sudden contraction of pipe, if there is a bend in the pipe or pipe fittings or an obstruction in pipe, these all are a cause of these all are the causes of minor energy losses. Okay. And first we will discuss about the major energy loss. This you can find out the value using a Darcy-Weisbach equation. Mainly we'll be following this equation to find out the loss of energy due to friction. Okay, so the equation is this. Okay, so that is 4FL V square by 2GD. So in this HF, okay, so here you can see HF here. So this is HF is the loss of head due to friction. And what is small f? Small f is the coefficient of friction. Okay. See, this f is a function of Reynolds number. That if you know the Reynolds number, you can find out the value of f. Or else in the case it will be given in the question. Okay. L is the length of the pipe, capital V is the mean velocity of flow, and D is the diameter of the pipe. So here all the details of the pipe will be given in the question, and you just simply have to substitute the values in this equation. Okay, so if in case f is not given in the question, at least Reynolds number will be given, and I'll be showing you the equation to find out the coefficient of friction using the Reynolds number. See here, you can see the equation to find out the coefficient of friction, which is a function of Reynolds number. So here, if the Reynolds number is less than 2000, that is a viscous or laminar flow. In this case, the equation is 16 divided by Reynolds number. If it is between from 4000 to 10 raised to 6, the equation is this. Okay, so you can find out the friction factor. All the other details are the dimensions of the pipe and the mean velocity of flow, capital V. So now you will see what are the different types of minor head losses. After finding all the equations for the head losses, we will be doing some problems regarding this head losses due to minor and major losses. So first we will see what are the different. Next we will see what are the different types of minor head losses. Okay. So first here it is loss of head due to sudden enlargement. So here the equation to find out the sudden loss of head due to sudden enlargement is I am giving the notation HE, that is equal to V1 minus V2 the whole square by 2G. Okay, so V1 is the velocity of incoming velocity, and V2 is the velocity in the enlarged area. Okay, so that is V1 minus V2 the whole square by 2G. So this is the head loss due to sudden enlargement. The next one is loss of head due to sudden contraction. So here due to sudden contraction, what is the head loss? So I am giving the notation HC, that is V2 square by 2G into 1 by Cc minus 1 the whole square. So Cc is the coefficient of contraction, so it will be given in the question. So this is the head loss due to sudden contraction. Okay, and at the entrance, third one was okay. The fourth one I will discuss the fourth one, that is at the entrance of the pipe. Here it is given giving the notation HI is equal to 0.5 V square by 2G. Okay, and at the exit it is H. I am giving us H naught, okay, H naught or HO as V square by 2G. Next one is at due to an obstruction in the pipe. So here due to the obstruction in the pipe, H obstruction or H obs is given as the notation is equal to V square by 2G into capital A by CC capital A minus small a minus 1 the whole square. So I will explain this better with the help of a problem. You will understand what is V capital A small a and all, what all these things are. Okay, and next equation is due to the bend, that is HV, that is K V square by 2G. Okay, so here we will see one example for the losses of head. So in this example, the rate of flow of water through a horizontal pipe is given as 0.25 meter cube per second, and the dia of pipe first initially is 200 mm and is suddenly enlarged to 400 mm. The pressure intensity in the smaller pipe is 11.772 Newton per centimeter square. Determine determine the loss of head due to the sudden enlargement. That's the first one. Second one, pressure intensity in the large pipe. Third one, power loss due to enlargement. So all the given data first we'll write down, that is Q is given as 0.25 meter cube per second and the diameter of the pipe is 200 mm. Initial diameter, so let it be D1. So D1 is 200 mm. So corresponding area A1 is equal to pi D square by 4. That is, you substitute the value here, you will get the answer as so and so. Okay, so that is 0.03141 meter square. Next one is enlarged to, it is suddenly enlarged to 400 mm. So D2 is 400 mm. So substitute the value of D2, that is 400 mm or 0.4 meter, 2 meter. It is substituted in this equation to get the area A2. Okay, so the sudden enlargement, the area is 0.1256 meter square. Now, what is the next data? Before writing down the next data, from this equation you can find out what is V1 and V2, isn't it? That is A1 V1 is equal to A2 V2 equal to Q. So discharge is given as 0.25 meter cube per second. From this A1 V1 equal to Q, you can find out the V1, and from A2 V2 equal to Q, you can find out the velocity at the second enlarged portion of the pipe. So V1 and V2 you found out, and the next given data is the P1, that is the pressure intensity in the smaller pipe. Okay, smaller pipe means the initial pipe only. So P1 is 11.772 Newton per second centimeter square. That is the last given data. Okay. So first one is loss of head due to sudden enlargement. That is HE. What is the equation? V1 minus V2 the whole square by 2G. So this equation, all the equations you have to by heart. Okay. So V1 minus V2 the whole square by 2G. Directly substitute all these values here in this equation. You will get the answer as 1.816 meters. And the second one part is to find out the pressure intensity in the large pipe. Okay, so to find out the pressure intensity in the large pipe, you have to substitute in the Bernoulli's equation. So what is Bernoulli's equation? You can equate the total energy at 2 points. Okay, isn't it? So, since we are finding out the losses due to we are finding out loss due to the sudden enlargement. What happens is that there is a head loss. Okay, but both the Bernoulli's equation part cannot be equated, but we have to add the head loss also to equate these two sides. So in the first pipe, it was going smoothly. Suddenly there is an enlargement, and there it comes the head loss due to sudden enlargement. So we have to add that energy part also to equate with the initial total energy. Okay, I hope this portion is clear. So why we are using the Bernoulli's equation is that P1 and P2, the P2 portion should be found out. P1 we already have. To substitute P1 and to find out P2, you have to use the Bernoulli's equation itself. Okay, so here P1 is known, that is it is given as 11.772 Newton per centimeter square by rho g, that is you know that 1000 into 9.81 plus V1 square by 2g. What is V1? You know that it is 7.957 square by 2 into 9.81. Z1 and Z2 both are same. Why? Because it is given in the question that it is a horizontal pipe. So Z1 and Z2 both are same. So this will cancel each other. And P2 by rho g, this part we have to find out. And what is V2 square by 2g? V2 you know that it is 1.99 square by 2g plus HE. So that we have already found out that as the first part. So this is 1.816. So direct substitution only, and you can find out what is P2 here. So here P2 will be all this one into rho into G. So you'll get the P2. So here I got the answer as 12.96 into 10 raised to 4 Newton per meter square, converting into Newton per centimeter square. Why? Because in this question it is given as 11.772 Newton per centimeter square. So converting the corresponding value to 9 Newton per centimeter square. And the third part was to find out the power lost due to the enlargement. So whenever the question is asked about the power loss, I always remember this equation, that is rho g q h e by 1000. So whatever be the loss here, you can substitute here to find out the corresponding power loss. So this is the equation. You have to by heart this one. This is direct substitution, that is 1000 into 9.81 into q. What is q? Discharge. It is given here in the question itself, that is 0.25 meter cube per second. So here substituting 0.25 here into HE, that is 1.816 by 1000. This will give you the power lost in kilowatts. Okay, so I hope this is question is clear to you. And the next one, we will see second question. That is the horizontal pipe of dia 500 millimeter is suddenly contracted to a diameter of 250 mm. So this is the case of sudden contraction. So what is the equation? So soon you find out what is the case, or what is the case. You directly write down the equation first. So you will get the idea what all data has to be data has to be found out first to start with the question. Okay, so here so this is sudden contraction, so you know that this is d1 and this is d2, and convert into corresponding into the SI unit, and the pressure intensities in the large and small pipe is given. So P1 and P2 is given. Okay, and find the loss of head due to the sudden contraction if Cc is 0.62. So Cc is given, and loss of head due to contraction has to be found out. So Hc has to be found out. So here Hc you have to find out, and this is the equation to find out the head loss due to contraction. Hc is equal to V2 square by 2g into 1 by Cc minus 1 the whole square. So here, to find out the Hc, what is the problem is that you don't know about the discharge. Okay, so Q is not given, and diameter is given, but you can find out the area, but you can't find out what is V2, V1 and all. Okay, so discharge is not given, so we can't directly apply this equation. Okay, so what is the next way to find out the head loss which is asked? Okay, so when you go through the given data, you can see here the pressure intensities are given, isn't it? So P1 and P2 are given. So you can substitute all these things in the Bernoulli's equation, isn't it? So P1 and P2 will come in the Bernoulli's equation. So you first you have identified you can't move forward with this equation. So next step is you go with the Bernoulli's equation. So how you can equate but these two part is by adding the head loss due to contraction in the second side. That is, this much head loss has happened due to the sudden contraction. So this is the equation. And here P1 and P2 is given. So I am grouping together P1, P2 term together. So that is P1 minus P2 by rho g equal to P2 square by 2g minus, you can see minus V1 square by 2g, then plus HC. Okay, Z1 and Z2 both are same, so this will cancel. Okay, so why Z1 and Z2 are same? Because it is a horizontal pipe. So here you can't see the middle step here. Directly I have given the expanded form, that is here this is HC, V2 square by 2g into 1 by Cc minus 1 the whole square. Okay, and minus, here minus V1 square by 2g. When I take this term to this side, it is minus V1 square by 2g. So what is the problem again is that it is in terms of V2 and V1. Okay, isn't it? V2 and V1. Both you can't find out. V1 and V2 both you can't find out. But the only way to solve it is to either convert it either into in terms of V1 or V2. So how to convert V1 to V2? That through this equation, continuity equation, that is A1 V1 equal to A2 V2. So from that you know that V1 is equal to A2 V2 by A1. Substitute this value, that is V1 equal to A2 V2 by A1 in this equation. You will get like this, isn't it? You will get like this. And substitute the value of P1 and P2 here. You will get the value as 2 here. And take out the common term V2 square and substitute the values given in this question in this particular portion. That is, all the data is given. Datas are given here. G, you know, that is 9.81. CC, it is given as 0.62. You see here it is 0.62. And A2 and A1 you can find out with the help of diameter, isn't it? You can find out the help of diameter. So all the datas are given. So some simple substitution. So here here you can see the value I got here is 0.0669. So from here I will get the value of V2 here. Okay, so once V2 is known, what is the advantage? That V2 term you can directly substitute in the equation. So one more thing I have to add. Here if I directly substitute in terms of V2, I am directly getting the value of V2. Okay, so V2 is the term we need to substitute in the equation HC. Okay, so in this equation I am substituting the value of V2. Cc is given as 0.62 and the value of HC is equal to 0.572 meters. So this you will get. And this is the first part. Okay, it is given, it is asked loss of head due to contraction as the first part, and the second part is determination of the rate of flow of water. So Q you have to find out. How to find out the Q? It is Q is equal to A2 into V2. So A2 you can find out from the diameter 250 mm. So here A2 into V2 will give you the discharge, that is 0.2683 meter cube per second.
I hope this is clear to you.